This is section 9.1, part C, type 1 and type 2 errors. So for this activity, you would take a deck of playing cards and cookies or some other prize for the winner. Your teacher will offer you the chance to compete for a reward. All you have to do is get lucky. The teacher will shuffle a deck of cards and announce the winning color, red or black. Any student who wants to take the challenge may choose one card without looking from the deck. If the card has the winning color, that student wins a prize. The chosen card will be replaced in the deck, and the card will be shuffled again before the next student plays. Continue playing until all prizes have been awarded, or all interested students have played. Sometimes it may be preferable to choose an alpha level of 1% or an alpha level of 10% for reasons that we will discuss shortly. Warning: if you are going to draw a conclusion based on a statistical significance, then the significance level alpha should be stated before the data are produced. Otherwise, a deceptive user of statistics might set an alpha level after the data have been analyzed in an obvious attempt to manipulate the conclusion. This is just as inappropriate as choosing an alternative hypothesis to be one-sided in a particular direction after you look at the data. So why choose a significance level at all? The purpose of a significance test is to give a clear statement of the strength of evidence provided by the data against the null hypothesis. The p-value does this. But how small of a p-value is convincing evidence against the null hypothesis? This depends mainly on two circumstances. First, how plausible is the null hypothesis? If the null hypothesis represents an assumption that the people you must convince have believed for a very long time, strong evidence or a very small p-value will be needed to persuade them. And what are the consequences of rejecting your null hypothesis? If rejecting your null hypothesis in favor of your alternative hypothesis means an expensive change of some kind, you need strong evidence that the change will be beneficial for that company. These criteria are a bit subjective. Different people will insist on different levels of significance. Giving the p-value allows each of us to decide individually if the evidence is statistically strong. Users of statistics have often emphasized standard significance levels such as 10%, 5%, and 1%. For example, courts have tended to accept 5% as a standard in discrimination cases. This emphasis reflects the time when tables of critical values rather than technology dominated statistical practice. The 5% level, alpha equals 0.05, is particularly common. There is no practical distinction between a p-value of 0.049 and 0.051. However, if our alpha level is 0.05, the first value leads us to reject the null hypothesis, while the second leads us to not reject the null hypothesis. Beginning users of statistical tests generally find it's easier to compare a p-value to a significance level that interprets the p-value correctly in context. For that reason, we will include stating a significance level as a required part of every significance test. We will also ask you to explain what a p-value means in a variety of settings. So there are two different types of errors that you can make. When we draw a conclusion from a significance test, we hope our conclusions will be correct, but sometimes it will be wrong. There are two types of mistakes we can make. We can reject the null hypothesis when it's actually true, which is a type 1 error, or we can fail to reject a false null hypothesis, which is a type 2 error. So if we reject the null hypothesis when the null hypothesis is true, we have committed a type 1, and if we fail to reject the null hypothesis when it's actually false, we have committed a type 2 error. So here are possibilities. It's possible that our null hypothesis is true, or it's possible that our null hypothesis is false. If the null hypothesis is true and we reject the null hypothesis, we have created a type 1 error. If the null hypothesis is true but we fail to reject it, that is a correct conclusion. If our null hypothesis is false and we reject it, then we've made a correct conclusion. But if our null hypothesis is false and we fail to reject it, that is a type 2 error. Now, depending on the situation, it's going to change which is worse, a type 1 or a type 2 error. So, a potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. The producer will then perform a significance test with the hypotheses that our null hypothesis is that the proportion of blemished potatoes is exactly 8%, and the alternative is that the proportion of them is greater than 8%, where P is the actual proportion of potatoes with blemishes in the given truckload. Describe a type 1 error in this setting and explain the consequences. So a type 1 error would occur if the producer concludes that the proportion of potatoes with blemishes is greater than 8% when the proportion is actually 8% or less. So they rejected the null hypothesis when it was actually true. The consequences for this is the potato chip producer sends a truckload of acceptable potatoes away, which may result in lost revenue for the supplier, and the producer will have to wait for another shipment of potatoes before production can start for the next batch. Describe a type 2 error in the setting and explain the consequences. Now remember, a type 2 error is when you fail to reject the null hypothesis when it's actually false. So a type 2 error would occur if the producer does not send the truck away when more than 8% of the potatoes in the shipment have blemishes. The consequences in this case would be that the producer uses a truckload of potatoes that make the potato chips, and more chips will be made with blemished potatoes, which may upset the consumers. Which is more serious, a type 1 error or a type 2 error? Again, that's going to depend on the situation. For the potato chip producer, a type 2 error could result in upsetting customers, leading to decreased sales. A type 1 error turns away a shipment even though less than 8% of the potatoes have blemishes. So this may not have much of an impact, and additional shipments of the potatoes can be obtained fairly easily. Let's check our understanding. We're back to that AAA battery. So there's a company, they have a AAA battery they make, and they're trying to decide if they should make a new deluxe AAA battery that supposedly lasts more than 30 hours on continuous use. They took a simple random sample of 15 batteries, and their null hypothesis is that these new deluxe batteries last exactly 30 hours. The alternative hypothesis is that it lasts more than 30 hours. Where mu is the true mean lifetime of the new deluxe AAA batteries. The resulting p-value they got was 0.0276. Describe a type 1 error in this setting. Remember, a type 1 error is rejecting the null hypothesis when it's actually true. So this would be that we conclude that the new batteries last longer than 30 hours when in fact their average lifetime is only 30 hours. Now we need to describe a type 2 error in this setting. A type 2 error is when you fail to reject the null hypothesis. So in this case, we would conclude, we fail to reject it, so we conclude that the new batteries do not last longer than 30 hours when in fact they do last longer than 30 hours. So which type of error is more serious in this case and justify? So even if your answers differ, if your justification can back your reasoning, you are still going to get points for these. So in this case, I feel that type 1 error is more significant because the company would be wasting money and producing new batteries that aren't actually any better than their original ones.